Welcome back. We've learned about vectors and matrices. Now it's time to learn about the data structure that rules them all in deep learning, the tensor. This one word is key to understanding how all modern AI frameworks operate. So, what is a tensor? The simplest definition is that a tensor is a container for numbers that generalizes vectors and matrices to any number of dimensions. It's the ultimate data structure. If you think of a single number, a scalar, as a point, a vector as a line, and a matrix as a flat surface, a tensor is anything with more dimensions than that. Let's build a clear hierarchy. A zero-dimensional tensor is just a single number, a scalar. A one-dimensional tensor is a list of numbers, what we know as a vector. A two-dimensional tensor is a grid of numbers, what we know as a matrix. The term tensor encompasses all of these and more. Things get interesting when we go to 3D and beyond. A 3D tensor is like a cube of numbers. This is why tensors are so critical. A simple matrix can represent a black and white photo. But to represent a color photo, we need to stack three matrices on top of each other, one for the red values, one for green, and one for blue. That stack is a 3D tensor. And it doesn't stop there. Real-world data is often even more complex. A color image is a 3D tensor. A video, which is just a sequence of images, becomes a 4D tensor. And when we train our models, we feed them a batch of videos, which could be a 5D tensor. Tensors are the only data structure flexible enough to handle this complexity. This is why, in deep learning libraries like TensorFlow or PyTorch, the term tensor is everywhere. It is the fundamental object. All data, images, text, audio, is converted into tensors before it enters a neural network. The network itself is just a series of mathematical operations designed to transform these tensors. And with that, you have mastered the data structures of AI. From scalars to vectors to matrices and now to the all-encompassing tensor. You understand how AI organizes information. In our next lesson, we're going to make a big shift. We'll move from talking about how data is structured to how a model actually learns, by starting our exploration of the second pillar of AI math, calculus.